Hello everyone, welcome back. In the next few weeks, we're going to switch gears a little bit in this series, and we're going to move from drawing to talking about sound. And we're going to explore different ways that we can use sound as the output for our generative systems. Now we're going to introduce some new libraries to do this. There's a good sound library that comes with P5.js, called p5.sound, but I've had a few issues with it at least on my machine recently. So we're going to use an external library instead for the next series of lessons. The library we're going to use is called Tone.js. So this is the GitHub site for Tone.js. It is a higher level wrapper around something called the web audio framework, which allows you to generate sound inside a web browser. The p5.sound library also wraps around the same web audio framework. They just have some different ways of working. So we're going to be learning in the coming weeks about Tone.js and the different ways we can use it to create generative sound. In this lesson today, we're going to just get through some of the basics, and we're going to set up some simple oscillators. And then in subsequent lessons, we're going to talk about synthesizers and musical notes and creating sequences, and then being able to manipulate and transform these sequences. The other library we're going to be talking about in the coming weeks is going to be called Tonal.js. And I realize this is unfortunate. One of them is called Tone.js. The other one's called Tonal. They're very similarly named, but they're both very useful. We're going to primarily rely on Tone.js to create sounds, but Tonal is going to come in handy when we need to bring in some ideas from music theory. So Tonal is going to be a library that we can use to do things like get all the notes, for example, from a C major scale, or be able to sort of transpose notes or invert intervals and things like that. So we'll talk about this in the coming weeks. So what I've done is I've modified our blank P5 sketch moving forward. In the index.html page, I've added these two libraries. So now from now on, when you remix a blank sketch, you're going to automatically be including these two libraries as well. So Tonal and Tone. So let me do that myself. I'm going to remix and create a new project here for the example we're going to be building to get us started. All right. Let's give this a name and a description. So we're going to be building some droning oscillators as our first step into Tone.js. Then let's move into our sketch and get rid of things we're not going to be using. Now, the first important concept to talk about when it comes to Tone.js and then just audio in the browser in general is that generally speaking, the audio libraries are not going to start generating sound, or may at least behave strangely, until there's been some kind of user input into the sketch. And that could mean, like the user clicking the mouse. This has been done so that, you cannot write programs that will just automatically start blasting sound at you. You have to interact with them first. So we're going to set up a little framework in our sketch to sort of follow that pattern. And we're going to do this in a very simple way. We're going to create a little Boolean variable called ready. And to begin with, ready is going to be equal to false. And then we're going to implement mouse pressed. And then in mouse press, we're going to check if we're not ready, right? So the exclamation mark means not. So in other words, if ready is equal to false, well, we're going to set ready equal to true, first of all. And then in draw, we're going to check, right? If we are ready, we'll be able to, do the audio stuff. And then otherwise, we're going to prompt the person opening your sketch to click into the window. And we're going to do this using the text function. So let's set a black background. I'm going to do a white fill, disable the stroke, and we're going to write some text that's going to say click to start. Oops. And we're going to put this text centered in the middle of the window at width and height over 2. And we'll set the alignment to be center justified. So let's take a look at what that looks like. All right. So now I have a simple prompt, right, that will appear because ready is equal to false, right? In the beginning, ready is equal to false. So we go into the else here in draw. And in mouse pressed, it's checking whether or not ready is false. And when we do click, it will switch it to true. Okay? And what that allows us is now we can start our audio objects here. So now we've created some kind of structure where we can delay, doing things like turning on our various oscillators or initializing some audio objects until the user has actually clicked into the window. And that's just an important thing to respect when it comes to working with audio in the browser. Okay, now we don't have any audio yet, of course, so let's just start and create our first oscillator. Now I'm just going to jump over to Tone.js here for a second. So Tone.js has a pretty extensive API here. So for future reference, it has a number of examples you can look at. So the API is the list of all the different Tone.js objects that exist. And the first one we're going to play with is going to be an object called an oscillator over here. So oscillators allow us to create waveforms that will create sound. We can give them a frequency, and we can start and stop them, and we can change their type. So we're going to explore that a little bit in a second. So we have also a bunch of examples. So if you want to look at some of these demos, if you're interested in looking at how these examples work, if you're doing some of your own explorations, for example, the oscillator example, right, just plays a pitch. If you want to see the source, you can right click into your window, look at the page source. And that will bring up the, the JavaScript code here that's creating this oscillator. And then finally on Tone.js, you also have a bunch of links to some demos. These are just projects that people have made using Tone.js. So those can be fun to look at just to see some of the possibilities. Okay, so the first object we're going to create is an oscillator. And throughout this example, this first example, we're going to go through a lot of the basic concepts with Tone.js. So let's create a variable here. We're going to call our oscillator OSC for oscillator. And in setup, we're going to say OSC equals new. Now all the Tone.js objects are inside this tone package, so we're going to use tone dot, just like with P5, we use P5 dot to create the P5 objects. We'll say new tone dot oscillator. And then in mouse press down here, we are going to wait until the user has actually clicked to say oscillator dot start. Now, if we do this, nothing happens. If I click, nothing happens. And that's because in Tone.js, we have to connect things together. So just an oscillator by itself, it will oscillate, but in order for it to make sound, we have to connect it to the last element in the sound chain. Well, currently, we don't have any elements in our sound chain, but the last element is this object called tone.master. Okay? So tone.master is, we can think of it as basically it's our speakers, right? It's the output of our sketch. So if we want to hear that oscillator, we have to connect it to tone.master. And now when I click, I can hear a pitch. By default, the oscillator is a sine wave, right? So we hear this kind of soft sound. That's a sine wave, and that sounds like it's tuned by default to 440 hertz, which is an A4. We'll talk about musical notes a little bit more in the next lesson. So if I click to start, I can hear my oscillator. If I want to stop it, I can just refresh the page because we've created this framework where it's going to wait for me to click before starting. That's also useful when we're dealing with audio because we don't want to have sound blasting constantly as we're programming. So it's helpful to be intentionally start it and stop it. Otherwise, it might drive you a little bit crazy over time, or your roommates. So it's important to connect our objects together. Now, this is a very simple chain. We have an oscillator connecting to the master, okay? But Tone.js allows you to create some really complex signal routing. We're not going to get into much of this today, but you can have, mixer objects, you can have filter and effects objects, and you can chain them together using this kind of connection metaphor. It's like you're patching a cable from one object to the next. Now, connecting to the master is a very common operation. And in the example, you're also going to see this. Every object has a built-in function called toDestination. Okay, so toDestination is a shorthand for connect to tone.master. So the destination in Tone.js is our speaker or sound card or the thing that's outputting the audio. So a synonym for this, right? Another way of writing oscillator.connect tone.master is to use the toDestination function. So that still works. And you're going to see this used in all of the Tone.js examples. So if you're wondering what is this destination, well, it's the last step in the chain. Another interesting thing to point out too is that the Tone.js objects, they tend to return themselves when you create them. So you can do this thing called method chaining. So for example, after we create the tone.oscillator, we could put a dot here right at the end because this little bit of code, right, evaluates to the oscillator. It actually returns the oscillator, and we could immediately connect it to the destination if we wanted to in a single line. Okay? And then you could keep chaining commands like this just to save on, make things a little bit more concise. So this is worth pointing out as well because you might run into this in some of the examples. Now, I prefer to do it this way. I find it a little bit more clear, and we don't really need to save space in these examples. We're going to err on the side of writing more legible code or easier to understand code. Now, another thing we can do with the tone.master is we can set its volume. Okay. Now, the volume is a signal. Okay, is a parameter signal in Tone.js, and what that means. See if we can find it in the documentation. Go back to this, into the API. Nope. Let's see, let's open the oscillator. That has a volume as well. Volume, okay. So volume, well, in this case is a parameter. Okay. So what that means is the Tone.js parameters, some of them you cannot change directly. So you see in this example here, in order to change the volume, you say volume.value. And what that means is some of the parameters, they're actually objects that can be manipulated. That's going to be interesting in Tone.js because we can do things like connect another oscillator to change the volume of a sound source, for example. Or we're going to be able to animate some of these parameters over time by, say, taking the volume and then ramping it up over time. Right, so let's try that. So if I want to change the volume of the master, I can make it equal to something. Now this is going to be in decibel by default. So if I put a 1 here, it's going to be just normal. Okay. If I put -3, I'm cutting the sound down a little bit. -6, right? Decibels are in increments. They sort of double in perception whenever you double the amount of decibels. Right? So the lower the value, the lower the volume. That can be helpful sometimes if your sketch gets a little bit loud. You can go and turn down the master volume. Now, because the volume is a parameter, we can also animate it over time. So we could say, ramp to, and we could send the volume down, for example, to -30, and do this over a period of time. Let's say over 2 seconds. Okay? And now it's actually ramping the volume down. So the parameters, a lot of the parameters of Tone.js objects can be animated in that way. So we don't set their value directly like so. We have to use their value property to modify them. I'm going to just turn this down a little bit, just so it's not too loud for you guys as we're doing some experiments here. Maybe I'll put it to -9 and change it later. So this allows us to affect the master volume of our sketch. Okay. Now let's talk about oscillator frequency here for a second. So whenever we create an oscillator, one of its parameters is the frequency. Now the frequency, right, is also a parameter that can be animated, which means we cannot just set it to something. We have to set its value to something. So I could say, set it to 220, which is going to be 220 hertz, which is going to be an A3. So that's half, right? We divided the frequency by half, and now the sound is like 1 octave below. And we'll go over these ideas in the next video a little bit more in detail when we talk about notes and octaves and their relationship between them. So for today, we're just going to play with just frequencies. So we can change the pitch of an oscillator, and we can also do this over time, right? So for example, in Draw, I might do something like change the oscillator frequency value. We're going to map the mouse cursor. So that's a number that goes between 0 and width. We're going to map it to a number between 110 hertz and 880 hertz. So I'm spanning a few octaves of this A note. Right. So we can affect the frequency by moving our mouse in this case. Okay. Now, there's not much to look at here because we're just dealing with sound. So it might be interesting to talk about, how can we draw the sound that we are hearing? Okay? So this is something we can do also with Tone.js. Now, there is an object in Tone.js called a waveform. And a waveform basically allows you to take a look at a sound source and then get its waveform as an array of numbers. So this is the shape of the sound that we're hearing. So we're going to create a global variable here. I'm going to call it wave. And then in setup, I'm going to say wave equals new tone.waveform. Now, in order for us to be able to see something in this wave, we have to connect it. We have to tell it, which object is going to be driving it. So for now, we're going to say oscillator, right? We're going to connect to the wave. So now this is taking the output of our oscillator and then connecting to the input of the waveform object. And then in Draw, we're going to draw the waveform. Now this is, we could put the code right here, or we could create a function here if we wanted to. In this example, we're just going to write the code right into Draw. We're not going to create a separate function. So in order to access the waveform, what we're going to do is we're going to grab something called the buffer. So the buffer, we're going to extract using getValue index 0. And this buffer is going to be an array of points along the sound wave. So let's draw those points. We're going to write a for loop here. So we're going to go through every sample. And let's set a white stroke to be sure we can see something. And we're going to create the x variable. We're going to map our counter. So we can go from left to right. So that's going between 0 and buffer.len. And we're going to map it to 0 and width. And then for the y variable, we're going to take the value of the amplitude, the point, and we're going to map it to a y coordinate. So that's going to be a buffer bracket I. And then that is a number that's going to vary between -1 and 1. This is kind of standard when we talk about sound samples. They oscillate around the 0 point, and the waves are going to go from -1 to 1. So those are the numbers that are stored inside the buffer. Let's map those to a number between 0 and height. And then we'll start by just drawing a point. See what that looks like. Okay. All right. So we can see something that kind of approximates to a sine wave here, and it's taking up the full amplitude because our sine wave has full volume. We turn down the volume on tone.master, not on our actual oscillator. So for example, if we wanted to see the actual sound we're hearing, we could connect tone.master to the waveform. And now we can see this has been attenuated because we've lowered the volume. So we get a sine wave. Now this is just drawn with points. So let's do a version where we're actually connecting the dots. In order to do this, we need to be able to connect two subsequent points. I'm going to turn this off. Two adjacent points in the buffer with a line. Okay. So let's do this by, we're going to count from 1 instead of 0. Okay. And we're going to go all the way to the end. And then that's going to become, let's call it x2 and y2. And then x1 and y1 are simply going to be the point that is at index -1, I -1. And then instead, we're going to draw a line from x1, y1, x2, y2. So the reason this works is because we've shifted where we start counting. So instead of going from 0, we start from 1, right? From the second value in the buffer, which means we can look back using I -1, right? That's the previous value. We're not going to go out of bounds of the array because we start from 1. And that allows us to look at both the previous value and the current value in the same iteration of the for loop. So now we can draw these points and connect them with a line. Now, one of the things that happens here with our visualization is we can see the frequency, right? But it's moving around left to right quite a bit. And that's because we don't really have a reference point from when we're starting to draw the waveform. This buffer here has an arbitrary length. It's probably, I'm guessing, 1024 samples, but it doesn't really matter how many we're getting in here. And we might be starting here at 0, depending on how draw gets synced up with the actual sound. We're kind of starting at different points along the waveform, which means visually it looks like it's just shifting around when in fact the wave shape is remaining the same. So just to make the rest of this example a little bit easier to follow, we're going to refine our drawing waveform here to look for the point where we go from kind of a rising slope and where we cross the 0 point. Okay? And we're going to make sure we always start drawing from that point in the waveform. This way, the wave is going to be a little bit more stable. This is similar to what oscilloscopes, right? Those tools you use to visualize waveforms in a circuit. That's a similar idea that they do. They have kind of a trigger point that they latch on to then draw the rest of the waveform and make sure it doesn't fluctuate like that. There are many ways we can write a trigger, but we're going to do it in a very simple way. Because we know the sine wave, right, is going up and down around. At the bottom here is at -1. At the top here, it's +1. And then in the middle, it's 0. There comes a point in the wave where we go from a negative number to a positive number, right? That's when we cross the 0 point going up. I'm going to choose this arbitrarily as the start of my wave. So we need to look for that point and detect it. So let's call that the starting point, and we're going to start at 0. And then we're going to write a little for loop similar to the one we just wrote that's going to scan through this buffer and is going to look for two adjacent samples where the previous one is negative and the current one is positive. Right? That's going to tell us that we've crossed the line, right, going from below 0 to above 0. And then we're going to record in start what the index was for that point. So let's ask the question. We're going to say if buffer I -1, that's the previous point, if it's negative, right? And if buffer I, that's the current point, if it's greater or equal to 0, then we found two numbers that are adjacent, where one is below 0 and one is above 0. So that's going to become our new starting point for the drawing of our waveform. So we're going to make start equal to I. And now that we've found a point, we can just get out of there. We don't need to look further down the buffer. We found what we were looking for. So we're going to use the keyword break. Break basically interrupts a for loop, right? And it's just going to kick us out of this loop right over here so that the code can continue. So break is helpful when you're using a for loop to like search for something through an array. And then once you've found it, you can just call break to get out of the loop. So you don't have to finish the looping through all the different values. So then here, when we, let's put a comment here so we remember what this does. So look for a trigger point where the samples are going from negative to positive. And then down here, we're actually drawing the waveform. So we're going to do another little change here. We are going to say, so now we have a starting point. Okay? Let's create an end point as well. Well, actually, let's just try this first. So we're going to make this I equal 1 here. We're going to start at the starting point instead. All right. So now we can see we're starting from the same point every time, but it still looks a little bit funny. And that's because that starting point, right, is going to be at different places through the buffer, which means we're going to be drawing different lengths of waveforms in different frames. So what we're going to do to fix this is we're going to draw only a portion of the buffer, right? So we're going to draw, let's say, we're going to create an endpoint, and we're going to only draw half of the buffer here. So we're going to set our end condition to be half of the buffer, and this works because we're talking about cyclic, waveforms. So we have more than enough information in the full buffer to see the shape of it. We're also going to put our starting point here, right? We're going to add this as an offset so that we're always going to be drawing the same number of samples. So if, let's say, we started at 10 here, we want to end at 10 plus half of the buffer length. And then we're going to go and change our loop here to reflect this. We're going to say I smaller than end, and then we'll also change the mappings to go from start to end, then over here to go from start to end. And what that's going to accomplish is now we can see a more stable waveform. Okay? And we're always going to be starting from the same point when we're drawing the wave. Now, this is going to be helpful also when we add a second wave, which we're about to do, and then we can start to visualize the interactions between the two different oscillators. Let's make this a little bit more compact here. And let's leave a comment for down the road. So we're going to calculate a new endpoint such that we always draw the same number of samples in each frame. So let's add a second oscillator to this example. We're going to call this one OSC2, not being super imaginative here. And we're going to create, I'm just going to copy and paste here. We're going to create a second oscillator, OSC2. We're connecting both of them to the destination. And then in mouse pressed, we are going to start OSC2. Now, what's happening here is we're not really seeing, we're seeing the two oscillators combined, right? So one of them is always going to be 220 Hertz. And then the other one is being, this frequency is being changed by the mouse position right now. So we're seeing the detuning of the oscillators, right, is creating some interesting different beating patterns and out of phase patterns with these waves. And we can hear the result as well. I'm kind of scanning through here for the 220 point, try to get them in tune with each other. So here they're almost the same, but not quite, because I don't have enough resolution with my mouse here to do that. And we get this beating effect because when the waveforms, they're almost the same but not quite, and you add them together, at times they will cancel each other out, and at times they will reinforce each other. And when you get frequencies that are very close together, you can start to hear interesting patterns getting created in the sound just by those two waves interacting with each other. So let's play around with this a little bit. Instead of changing the first oscillator with my mouse, what we're going to do is we're going to animate that oscillator using something called a low-frequency oscillator, or an LFO. So an LFO is just like a regular oscillator, except it moves at a much lower rate. So these oscillators we're hearing, their frequency is in the audio domain. So 220 hertz, 440 hertz, those are frequencies we can hear. If we oscillate at like a fraction of a hertz, we're going to still have the same up and down motion, but we can use that motion to, say, control a parameter instead. So it's not going to be an audio rate, it's going to be a much slower rate. So let's create a low-frequency oscillator. So we're going to call it the LFO. Let's put a little comment here, low-frequency oscillator. So LFOs are really useful to add some life and modulation to your sound. So we'll say, let's make a new LFO. The LFO here, we're going to provide some initial parameters. Those we could also set later, right, using the this syntax. We're going to say oscillate at 1/10 of a hertz. Okay? I'm putting in the time unit here. We'll see down the road, there's lots of different time units we can put in Tone.js, where we could put time in seconds and hertz, but also in divisions of a clock, like numbers of quarter notes, 8 notes, these types of things. And then we're going to set a minimum and a maximum for this LFO. So here I want the LFO to oscillate between, let's say, 210 and 230. So I want it to kind of go around the frequency of my, let's say, my second oscillator, and then we're going to use this LFO to modulate the pitch or the frequency of the first one, so that it goes up and down between 210 and 230. So it's going to overwrite the value that I put in here. So let's comment it out. So now, having done an LFO, we're going to connect it, and we'll say LFO.connect. And we're going to say, take this LFO and I want you to control the frequency parameter of my first oscillator. And because these parameters, remember we mentioned in the beginning, they're objects of their own. So we have, they can be signals. We can get an oscillator to control a parameter of another object. And then down in here, we are going to start the LFO at the same time as we start our other two oscillators. And here that should be not 0, but O, of course. So now it's going to go from 210 to 230, and it's basically moving, doing what I was doing with my mouse before, except it's automating it for me. And then we can get to see what happens to our, and we can hear what happens to the tone when we're sort of getting those two oscillators to kind of go in and out of tune with each other. Now let's talk about, just to wrap up here, with the oscillator object. Of course, so far we've used a sine wave. So this is something maybe you can explore or just experiment with next, is just setting different oscillator types. Okay? So we have 4 different types. We have sine, that's the default. Then we have a square, triangle, and a sawtooth. Okay? So let's take a look at all of these in turn. Now there's a few different ways. I'm going to disconnect here the second oscillator for a second, so we only see the first one. So there's a few ways we can set the oscillator type. One is we can simply say oscillator.type, So by default, it's a sine, but let's say I change it to a triangle. Now it looks like this. And you can see the different shapes, right, are going to have different properties. So a triangle sounds a lot more pointy and sharp. The sawtooth looks like this, right? And that one is even more aggressive. And you can see different oscillators also have different perceived volume, right? So this one, for example, sounds a lot louder. So with different oscillator types, we might want to turn it down a little bit, just because it sounds a lot louder than a sine wave. And then the last one is the loudest, is the square. So actually I should leave the volume here. Square wave looks like this. So square wave, it gets you these retro, 8-bit Nintendo type sounds. So this is one way we can go and change the parameters after the fact. We can also pass the parameters here as an object into the constructor of the oscillator. And this would look like this. We can use the curly bracket notation, right? And then we can say, actually, let's bring this one up here. Now we can now say something like type, right? And then we can say, I don't know, this one's going to be a triangle, right? And then here we could say, we could set the frequency, and now we don't have to say frequency.value. We can just say frequency. We could set the volume, right? And there's a few other parameters we can change, things like the phase. They're all in the oscillator documentation. So we can create oscillators that way also, and then put in initial parameters using an object. So let's do this with our second oscillator. Clean up the comments here a little bit. And the second oscillator, we're going to make them both triangles now. And I'm going to connect it again to the destination. So this is the pattern we get by, mixing triangle waves. Turn up their volume a little bit. So this would be a good time if you want to sort of get familiar with Tone.js a little bit. Things you can experiment with would be, see what happens if you add a third oscillator, right? Because you can get some really interesting things happening once you throw a whole bunch of oscillators. You could also try different waveforms, right? Different frequency ranges. Let's put in some square waves here. That sounds a little bit harsh. And you can also combine, we could mix a sine with a triangle, for instance. And we get, both interesting sonic characteristics, but we also get some kind of cool visuals as well, just looking at the blend of these two waveforms. Okay, so that's it for this first lesson. This was really just getting to know Tone.js a little bit, and we did this by creating a couple of oscillators and turn it off now. We also got an LFO, or a low-frequency oscillator, to manipulate the frequency of one of our oscillators so that it can change over time. In the next lesson, we're going to talk a little bit about, now that we've done this, creating sort of well-defined musical notes, something that may be more similar to playing a synthesizer with a keyboard. And the goal for this is going to be moving towards generative melodies eventually. So I'll see you in the next lesson.